The next thing that we're going to look at is the concept known as greatest common factor. In order to do this, in our toolbox we do need to know how to find all factors of a number and also how to write a number using prime factorization. Upon completing this presentation, you will understand the difference between a common factor and the greatest common factor. You will be able to find the GCF, or greatest common factor, for a pair of numbers using lists and/or prime factorization. So let's talk about what a common factor is. A common factor is a number that divides a given set of numbers. And the greatest common factor is the largest number that divides a given set of numbers. So to go ahead and kind of explain this a little bit further, we're going to use two different methods for finding the GCF. The first one is going to be using lists. So in order to do this, we're going to use our first method for when we talk about factors, which is list out all of the factors for each number, and then identify factors that appear in both lists. The largest number in our list of common factors is the greatest common factor. So let's look at some examples here. If we look at example A, we have the numbers 3 and 4. So to start off with, let's work with 3. The only numbers that divide into 3 are 1 and 3. These are the only factors of 3. For the number 4, we have 1 and 4, and it's also divisible by 2. So as mentioned, our next step is I want to know what numbers do they have in common. These are the common factors. The only number that they have in common is 1. 1 is a common factor, and as it is the largest number that they have in common, it is also the greatest common factor. For our second example, let's look at 2 and 8. 2 and 8, let's start by finding the factors of 2. Things that divide into 2 is 1 and 2. Things that divide into 8, we have 1 and 8. We also have 2 and 4. So now what numbers do they have in common? These will be our common factors. The first one they have in common is a 1. They also have a 2 in common. So now, looking at this list, I want to know what is the largest number that they have in common. And the largest number that they have in common is a 2. So 2 will be the greatest common factor. Let's move on to our next example, example C, which is 28 and 42. The first two cases that we looked at here, these are kind of special cases, and we'll go over some basic rules about the previous two examples when we get to the end of this section. So when we look at C and D, there's a little bit more involved in terms of finding common factors and greatest common factor. So let's go ahead and start by listing out the factors for 28. 28, we have 1 and 28. 28 is also divisible by 2, and if you divide by 2, you get 14. 28 is also divisible by 4, and if you divide by 4, you end up with 7. Similarly, let's repeat the process for 42. 42, I have 1 and 42. 42 is divisible by 2, and if we divide by 2, we get 21. If you add the digits, you get 6, which is divisible by 3, and therefore 42 is divisible by 3. If you divide 42 by 3, you get 14. It's not divisible by 4, it's not divisible by 5, but it is divisible by 6, and if you divide by 6, you get 7. These are all of the factors for 28 and for 42. So now, again, the next thing that we want to do is find common factors. So our common factors, they both have a 1 in common, they both have a 2 in common, we have 7 in both lists, we also have 14 in both lists. So these are our common factors. And then we want to know what is the greatest common factor. So what is the largest number in our list? That will be 14. For our last example, let's look at 48 and 60. Starting with factors for 48. 48 is divisible by 1, and we have 48. 48 is divisible by 2. If you divide 48 by 2, you end up with 24. If you add the digits of 48, you get 12, which is divisible by 3, so 48 is divisible by 3. If you divide 48 by 3, you get 16. We have 48 is also divisible by 4, and if you divide 48 by 4, you get 12. It is not divisible by 5, since it does not end in 5 or 0. But since it is divisible by 2 and 3, I know that it's also divisible by 6. 48 divided by 6 is 8. There are all of our factors for 48. So now if we move on to 60, 60 is divisible by 1 and 60. 60 is divisible by 2, and if you divide by 2, you get 30. It is divisible by 3, and if you divide by 3, you get 20. It is divisible by 4. If you divide by 4, you get 15. It is divisible by 5, and if you divide by 5, you get 12. And it is divisible by 6. If you divide by 6, you get 10. It is not divisible by 7, it's not divisible by 8, and it's not divisible by 9, and so we do have all of our factors here. So now, what numbers do they have in common? Well, they both have a 1 as a factor. They have 2 as a factor. They have 3 as a factor. 4, 6, and 12. These are all of the numbers that appear in both lists. So from there, we want to know what is our greatest common factor. We get 12. So this is the first method for finding greatest common factor. And it's a perfectly fine method. Now, if you have, for instance, 48 and 60, those were rather large numbers, and notice that they had a lot of factors. And so using this method is great if you're dealing with small numbers and a limited number of factors. But when we get into ones that have a lot of factors, this may not be the most timely manner in order to do this, but it does still work. The second method that we have for finding the GCF is using prime factorization. In order to do this, we want to start by writing each number as a product of prime factors. From there, we want to put factors that appear in both lists in the GCF, and we want to multiply those numbers together. One thing to note, if there are no common factors, then the GCF is 1 by default, because 1 is always a factor of any number. So let's look at our same examples again and see what we can do with prime factorization. If we look at example A, I want to go ahead and factor these numbers. 3 is a prime number, so it's just equal to 3. 4 is equal to 2 times 2. So when finding the greatest common factor using prime factorization, the next thing we want to know is what numbers do they have in common? Well, looking at my list here, I don't have any common factors. So remember that means that by default, our GCF is 1. Let's look at B. B, we have 2 and 8. So again, I'm going to start off by writing my prime factorizations. 2 is equal to just 2. It is a prime number, and so we cannot break this down. 8, this is equal to 2 times 4, and 4 is equal to 2 times 2. Now, when we did prime factorization for just a single number, we could write it using exponents. When we do prime factorizations to find the greatest common factor, I recommend writing it out in expanded form. So from here, I want to know what numbers do they have in common. Well, they both have 1, 2 in common. I'm going to put that inside my GCF, and for this problem, we're done. 2 is the greatest common factor. So now let's go ahead and move on to some more complex examples. If we look at C, the first thing I want to do is write 28 and 42 using prime factorization. 28 is equal to 4 times 7. 4, I can break this down further into 2 times 2. And each one of these numbers is prime. So my prime factorization for 28 is 2 times 2 times 7. Let's repeat the process for 42. 42 is equal to 6 times 7, and 6 is equal to 2 times 3. We cannot factor any of these any further, and so my prime factorization for 42 is 2 times 3 times 7. From here, I want to know what do they have in common. Which factors do they have in common? Well, they have a 2 in common, so I'm going to put that in my greatest common factor. And they have a 7 in common. I want to put that inside my greatest common factor. From there, we can multiply the results, and 2 times 7 results in 14. 14 is the greatest common factor for 28 and 42. For our last example, let's repeat the process again. I want to start by factoring 48. 48 is equal to 6 and 8. I can factor 6 to 2 and 3. I can factor 8 to 2 and 4. And I can factor 4 to 2 times 2. At this stage, all of our numbers are prime. So 48 is equal to, I'm going to do some rearranging here. I have a total of 4 2's being multiplied and a 3. Let's look at 60 now. 60 is equal to 6 times 10. I can factor 6 into 2 and 3, and I can factor 10 into 2 and 5. At this stage, all of our numbers are prime. And so 60 is equal to 2 times 2 times 3 times 5. Again, I want to rearrange them. From there, we want to find the GCF. So what do they have in common? Well, I know I have the first 2 in common. I have a second 2 in common, and I have a 3 in common. So our GCF is going to be the result of multiplying 2 2's and 1 3 together. If we multiply this out, 2 times 2 is 4, and if you multiply that by 3, you get a total of 12. So these are our 2 different methods for finding greatest common factor. Greatest common factor is something that we will see throughout the semester. The first time that we will see it is later in this section when we talk about simplifying fractions. We will be using prime factorization again. It's a handy tool to use when we talk about more complicated fractions. And we will also be wanting to be able to kind of just look at a set of numbers and be able to see the greatest common factor. We will extend the concept of greatest common factor to include variables and factoring out a GCF from polynomials when we get to Chapter 6.